Hi, everybody. This is Miss McClellan here to go over Notes 2.3.2 S with you. More triangle similarity flowchart proofs. In this lesson, we simply are going to make a whole bunch of proofs. It's a practice kind of lesson. All right, beginning. Angle similarity. Angle similarity is abbreviated to AA similarity. If two angles in one triangle are congruent to two, I should say corresponding, angles of another triangle, then the two triangles are similar. So in this proof, we would do our triangle similarity statement. Triangle KJL is similar to triangle. Okay, I'm going to be really careful here. K is congruent to angle G. Angle L is congruent to angle H. Angle J is congruent to angle F. This last thing's not given, but I'm just trying to make sure I write these in order. So if I start with K, I better have G here. If my next letter is J, I better have F here. If my next letter is L, I better have H here. So I've got my triangle similarity statement. Notice it's not congruence. I don't have the equal sign attached to the tilde. And this is by angle similarity. And then you have to justify your conclusion with your evidence. So angle K is congruent to angle G. That's given by angle markings. And angle L is congruent to angle H. That's also given by angle markings. We continue. Side, side, side. If you guessed this was abbreviated as SSS with a little tilde, you were right. If the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. All right. So let's start with our similarity statement. Triangle ABC is similar to triangle MNP. If that's true, then AB over MN should equal NP over BC. Oh, I'm wrong. You have to keep the same triangle on top. So I should have written BC over NP equals AC over MP. And I'll get to that using calculation. Hopefully it's true. Is AB over MN, which is 4 over 2, which is 2, going to have the same result as all the others? Okay, this was calculation. Let's check our others. Is BC over MN, which is 6 over BC over not MN, NP. Whoops. NP. That's 6 over 3, and that also equals 2. Looking good so far. Calculation. We just need the last one to be true. Is AC over MP, which is 8 over 4, also equal to 2? Yes, it is. Yay! All right, so since that was calculation. So each of the corresponding sides have equivalent ratios, so this chain of proportions is true, which is great. Now I can say that triangle ABC is similar to triangle MNP, and I forgot my justification. It's SSS similarity. We continue. Now we're going to do side-side angle. SAS similarity. If an angle of one triangle is congruent to an angle of a second triangle and their lengths of the sides, including, meaning angle is between the sides, including this angle, are proportional, then the triangles are similar. Okay, so we have a similarity statement to make. Triangle ABC, hopefully it's similar to triangle DEF by side angle side similarity. All right, so we'll have our statement about the angle. Angle A is congruent to angle D, that's given by angle measure equals 50 degrees. And if AC over DE equals AB over DF, if we can find that by calculation, then we will have a valid proof. Let's see if that works out. What's AC over DE? I have 6 over 9. That's 0.6 repeating. Okay. And the other one, let's check. I want to check AB over DF. AB over DF is 8 over 12. That does also equal 0.6 repeating. So the fact that these two ratios are equal means that this proportion is true. So that's a good proof. Done. All right, next. Now we have to figure out if the triangles are similar. Well, vertical angles are congruent. So I do in fact have two angle pairs here. So I can use angle-angle similarity to say that triangle NJM is similar to triangle, let's see, I had NJ. Now I'll do KJ. KJL. So that will be angle M is congruent to angle N, which is given by angle measure equals 65 degrees. And angle, and be careful because you need 3 letters here. NJM is congruent to angle LJK because they are vertical angles. Okay, let's see for this next one. So for this one, I don't know right away if these are going to be congruent, but I can solve for missing angles using the triangle sum theorem. So let me see. What does angle Z equal? Let's call this 48 plus 77 plus the measure of angle Z equals 180 That means that 125 plus the measure of angle Z equals 180. I subtract 125 from both sides, and I get that the measure of angle Z is equal to 55 degrees, which is great. That means it equals angle H. Okay, I can use angle. So let's write our similarity statement. Triangle XYZ is similar to triangle, now I have to be careful, X corresponds to G, Y corresponds to F, and Z corresponds to H by angle similarity. All right, we are given that angle X is congruent to angle G by angle measure equals 48 degrees. And then we'll have to say that angle Z is congruent to angle H, and that's because the measure of angle Z equals the measure of angle H. And then we'll have to say that the measure of angle Z equals the measure of angle H by the triangle sum theorem. Okay, we continue. Ooh, parallel lines. Woohoo! Okay, let's see what we're going to do here. A delight. Do you see these parallel lines right here? Let me emphasize them with another color. Dun, 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 dun. Okay. These lines are parallel. Parallel lines have congruent, corresponding angles. These lines are parallel. Oops, I'll do it with a line. These parallel lines also have congruent, corresponding angles. That's going to be key. I have these angles are congruent and these angles are congruent. Let's start our proof. We're going to be using angle. Our triangle similarity statement. Triangle QRP is similar to triangle PVW. I love it when the triangles are oriented the same as one another and it's easy to do my similarity statement. Anyway, let's by angle similarity. First off, I'll do angle Q. So angle Q is congruent to angle VPW, and that's corresponding angles. Now, this is only allowed if I talk about parallel lines, so I have to. The appropriate parallel lines to talk about are the ones that touch angle Q and VPW. So I have line segments QR and PV are parallel, which is given by arrow markings. Next, angle W is congruent to angle RPQ, again by corresponding angles. And that is only allowed if I provide evidence of parallel lines. So here's my evidence. WV, that line segment is parallel to PR, that line segment. And that's also given by arrow markings. This flowchart is complete. Next. Oh boy, side, side, side. I hope that these proportions are going to work out. Let's assume they do and work backwards. Our similarity statement, triangle ABC is similar to triangle DEF by side, side, side similarity. That's because AB over DE, hopefully, equals BC over EF equals AC over DF. If that works, we're going to get it from calculation. If all three corresponding side pairs are proportional, we'll be all set. All right, let's check AB over DE. That is 6 over 4, which is 1.5 by calculation. Let's check another. Let's do BC over EF. That is 9 over 6, which is also 1.5 by calculation. Okay, last but not least, AC over DF. That is 12 over 8, which is also 1.5 by calculation. Since all three of these have the same the same ratios, my proportion statement carries. So my proof is complete. Very good. Okay, moving on to number 5. Now I have this triangle pair. So for this one, I could choose between side angle side to do a proof. But since my proof boxes are already set up for me and they're set up for side, 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 which is also an option, I'm going to do side, side, side. I know that this is set up for side, side, side because in the column to the left of my ultimate conclusion, I only have one box, and that box is going to be to say that all three corresponding side pairs are proportional. We'll start on the left as usual with our similarity statement and theorem. Okay, triangle, I'll use black. Triangle ABC is similar to triangle BDC, and this is going to be by side, side, side similarity. And for that to hold, I'll need to have corresponding sides proportional. So let me assume that's going to be true as I work. I'm going to check that CD divided by, okay, that's the longest side, so it'll correspond to the longest side in my smaller triangle. So divided by BC equals BD over AB, the middle length side, equals BC over AC. And I'm going to check with calculation. Hopefully the corresponding sides are proportional. All right, let's begin with CD over BC. That is equal to 18 over 12, which is 1.5. That's by calculation. If the other two corresponding side pairs also have ratios of 1.5, we're going to be all set. All right, now I'll do BD over AB. That's 15 over 10, which is 1.5 again. Good calculation was my justification. And the last one I check is BC over AC, and that equals 12 over 8, which is also 1.5. Yay! Because I've done so many of these, I'm going to become prone to error, so I'm going to go ahead and check my work. 1.5, 1.5, 1.5. The proportions are all equal. Side, side, side. All right. And I've got my statement, justification, statement. Okay, good. Let's do the next one. So here I see that I have two sides and an angle. Vertical angles are congruent. If it turns out that I've got proportional side lengths, then I will be good to go. Okay. I'm going to be trying with side, angle, side similarity to show that triangle ABC is similar to, okay, now I have to be super careful. A is the vertex that touches the shorter of the two sides. So I should start with E, triangle E. And then B is not C. So, oh, you can't see it. It's D. But whatever you want to call it will be fine. E, D, C. All right, so since we're doing side angle side, I have to have my angle and my side statement. So for the angle, I'll do angle A, B, C is congruent to angle E, C, D, and that's because they are vertical to one another, and vertical angles are congruent. All right, now we have, I'm going to compare the shorter sides, and I'll go from ABC, for ABC as the top of my fractions. So AC over CE equals BC over CD. Okay. And that would be, if it works out by calculation. Let's check that those side pairs are indeed proportional. All right. AC over EC equals 25 over 20, which is 1.25. And BC over CD equals 40 over 32, which is also 1.5. Yay! Okay, this is by calculation. Also, it's a coincidence. Oh, sorry, not 1.5, 1.25. I'll fix that. And then there is no coincidence, actually. This is great. Let's check our answers. So 1.25, these are equal. Vertical angles are indeed congruent. I have my justifications for each. I'm doing side angle side. The angle is in fact between my side pairs. Great. Let's keep going. Okay. This is going to rely on parallel lines. Remember that corresponding angles are congruent. So I'll be able to make these claims. Here we go. Triangle AW XP, I'm going to say that that's similar to triangle WYZ. I'm going to be using angle similarity. First, I'll talk about angles X and Y. Angle X should be congruent to angle Y since they are corresponding. Now, we know that corresponding angles are only congruent if the associated lines are parallel. Let's say that they are because we have these arrow markings. So XP is parallel to YZ. That's given by arrow markings. All right. And now we can say that angle P is congruent to angle Z because those are also corresponding. And it's the same set of parallel lines. So you could really draw an arrow from this box to this one, but I'm just going to restate because usually you won't have the same parallel lines. So I don't know. I'm restating it. You don't have to. XP, you can either do this restatement or attach a line from here to here, is parallel to YZ. That is given by arrow markings. Next. All right. I see parallel lines, so my first instinct is that we're going to do something with angles. And I can see that it's going to be corresponding angles where this horizontal part is the transversal. Yeah. All right. This is going to be angle again. Triangle ABD is similar to triangle BCE by angle similarity. I have angle C is congruent to angle B. That's given by angle marking. And I have angle A is congruent. Oh, I made a mistake. I'll go back and fix that in a second. I'm circling my error and I'm going to continue. Angle A is congruent to angle CBE, and that is by corresponding angles. Over here, because I used corresponding angles, I need to make a statement about parallel lines. I have AD is parallel to BE, which is given by arrow markings. You can just write given, but since I'm making this as a reference for you, I want it to be more complete. Here's my error, angle B. Can you think how I should change this? If you said to yourself that angle B needs more letters, you were right. I cannot leave it to the reader to know which angle I'm referring to. I needed to specify CBE so that I knew this was the version of angle B I was talking about. It's only enough to say just a vertex for the angle if that's the only angle it could possibly represent. For example, angle A only represents this angle right here. Anyway, for this top one, angle C is congruent to angle ABD. And that's what's given by angle markings. Okay. Let's check this proof. I find that when I do a lot of things, like many problems in a row, my understanding increases, but so does my frequency of errors. These are, in fact, the parallel lines. Let's check if this is the right angle. CBE. CBE is corresponding to A. Yes, that's correct. All right. Let's check this one now. Angle C is corresponding to ABD. Yeah, that's correct. Okay. I'm satisfied. All right, next problem. This is a fun problem because the triangles look like they're not the same. However, they are the same. You know, because angle X is congruent to itself, so both triangles have angle X. And angle X, YT is congruent to angle V. So, it would take a reflection, but you could show that with rigid transformations. In any case, triangle XZV is similar to triangle, all right, now we have to be careful, XTY, because they're not oriented in the same way. So it's not XYT, it's XTY. And this is by angle similarity. Angle X is congruent to angle X reflexively. And angle XYT is congruent to angle V, which is given by the angle markings. Let's check and then continue. Is this true? Yes. Is this true, given by angle markings? And did I do X, Y, T right? X, Y, and then T, this angle? Yes. And that's the correct statement. Continuing. Is this the last page? I think it is. Very good. Last page. Woo, woo, woo. All right. Okay, let's see. Assuming these are triangles, these triangles are similar. I have triangle PQR is similar to, okay, I have corresponding angles, so I know what order to go in, right? It'll be between, I've got to have an angle between sides, so triangle PQR is similar to triangle NRM. And I know that's the order I need to go in because N to R is the smaller side pair that I'm trying to compare to P to Q, which is also, I want to compare the smaller of the two sides for each triangle. All right, this is going to be by not angle, side angle, side angle, side. Side angle, side similarity. We'll start with the angle pair. Angle Q is congruent to angle NRM by corresponding angles. And that depends on another box, which you were not prompted to do, but you have to do, even if you're not prompted. All right, we've got side PQ, side line segment PQ is parallel to line segment NR, and that's given. Okay. And this is going to require two things. Ugh, I don't like this setup. We'll make it work. I'm going to hope that PQ over NR is equal to QR over RM. And I'm going to check with calculation. So PQ over NR is 12 over 9, which 4/3, 1.3 repeating. Okay. And That's by calculation. And PQ over NR. QR over RM is 16 over 12. That's 4/3 again. That's 1.3 repeating by calculation. Well, it worked. It's just messy. Sorry about that. These are given as parallel. These calculations do show that they have the exact same ratio. Therefore, the side lengths surrounding the angle are proportional. The angles are congruent, so side angle side works. Great. How many do we have left? Just 3. Okay, simple. All right, we've got parallel lines, which give us alternate interior angles. Alternate interior angles. And we've got vertical angles, and that's enough to prove angle-angle similarity. So, by angle-angle similarity, triangle MON is similar to triangle QOP. One of the angles is vertical, so angle MON is congruent to angle PO. Oopsie. Q, and that's vertical angles. And then angle P is congruent to angle N because they are alternate interior angles. But in order to use alternate interior, remember you have to reference those parallel lines. So we have MN, the line segment MN is parallel to the line segment PQ, which is given by angle markings. Let's see if we did a good job. Oopsie. How do I get rid of that? Well, we might be stuck with that on the bottom of the page for the rest of class. That'll have to be okay. These are indeed parallel, which does imply that these angles are congruent. I only need one letter for each because there's no competition for either of these angles about what that letter could represent. MON, MON. That's that angle. Is congruent to POQ. That's that angle. That's true. Those are vertical. That's enough for me to say that triangle MON is similar to triangle QOP by angle-angle similarity. How do I get rid of this? Hold on. Okay, I'm back and that protractor is gone. All right, I've got triangle GHI, LJK. I've got 2 side pairs to compare and an included angle. So, let's go. I'm going to assume these are similar and start from the end. I can see I'm going to be doing side angle side similarity. For triangle GHI to be similar to triangle, okay, do I need to start with K or L? I need to start with K because K is the vertex that attaches to the shorter side in this angle, and G is in this triangle, and G is the vertex that attaches to the shorter side in the other triangle. And those have to align. So I have K, and then my congruent angle J, and then the last letter L. First, the angle statement, because that's straightforward. Angle H is congruent to angle J, which is given by that angle marking. Okay. Then I'll write this proportional relationship, assuming it turns out to be true. All right. JK over GH equals JL over IH. And I'll be checking that with calculation. Let's see. All right, so I've got JK over GH, which is 1 over 2. by calculation. I'll write that as the decimal 0.5 because decimals are universally comparable, but you could leave it as a fraction. All right, next I'm doing JL over IH, which is 2.25 over 4.5, which is also 0.5 by calculation. So this proof worked out. 0.5 equals 0.5, so the corresponding sides are proportional, and they have an included angle. So by side angle side, the triangles are similar. Okay, next. So the included angle is going to be reflexively C, and then I will be comparing. This is hard for me unless I draw these separately, so let me see. I've got S, 4, and 5 with vertices P and Q. And I've got S to R and T, and SR is 4 plus 12 units long, which is 16. And S to T is 20 units long because that's 5 plus 15. All right. I'm going to assume that these are similar, in which case it would be a side angle side similarity relationship. I've got triangle SPQ similar to triangle, want to have the shorter side for, okay, SRT. The angle is straightforward, so I'll do that first. It's just reflexively the same. So angle S is congruent to angle S reflexively because everything is congruent to itself. And let's see about this. I'm going to hope to show you that SP over SR equals SQ over ST. And if that works out, I will have done it with calculation. Okay, let's check on this. What's SP over SR? Well, that's 4 over 16, which is 0.25. And that was by calculation. And what's SQ over ST? Well, that's 5 over 20, which is also 0.25 by calculation. So it seems like everything worked out, but let me check my work because I do make mistakes. 0.25 and 0.25 are indeed the same number. So the corresponding side lengths are proportional, and there is an included congruent angle. So therefore, these triangles are similar by side angle side similarity. And that was the last one, so we're done. I hope you found this useful, and I'll see you next time. Bye.